most important strands are algebra and geometry. And I would say with algebra being the most important. So these are some of the concepts that we're going to go through throughout the course. Okay, so number sense, percentage, fractions and decimals, powers and radicals, solving equations, algebraic factorization, simultaneous equations, and more. Okay, and then for geometry, angles, lines and parallelism, transformations, similarity and congruence, geometry of polygons, length and area, volume and capacity, coordinate geometry. And again, algebra and geometry are the most important strands, so we're definitely going to focus on those. Some other strands that we're going to talk about involve graphs, sets, probability, trigonometry. And for today, I'm going to give content about chapter 3 in the grade 7 textbook, which is called Properties of Numbers. Okay, the reason I started with chapter 3 is because chapters 1 and 2, some of it is too easy, so there's no point in going through it. Okay, and this chapter covers a lot of fundamentals that you'll need to know. Okay, so let's start off with a warm-up. Okay, so don't feel pressure, just answer the questions. If you can, please do raise your hand. If you don't know, that's okay. And just, raise your hand and I will call on you, okay? So number 1, what number is a whole number but isn't a natural number? Does anybody know the answer to this question? It's a bit hard to see. Okay. Okay, just trying to see everyone here. No, nobody knows? Okay, so no problem. Oh, okay, I need to. Oh, so Matthias said in chat. Where's Matthias? Or come on, where are you? Okay, cool. Okay, you can type in the chat, but it would be even better if you spoke, okay? So Matthias said 0. Okay, and that's true. That's the answer, okay? 0. So thank you, Matthias. So a whole number is, it's not exactly like when you say whole number in day-to-day life. Okay, so in mathematics, whole numbers are the set of numbers starting from 0 and then increasing by 1. Okay, so 0, 1, 2, 3, etc., to infinity. And then natural numbers are similar, but they start from 1. So 1, 2, 3, 4, etc., and they keep increasing until infinity. Okay, so the only number that's a whole number, but that isn't a natural number is 0. Okay. So next question, round 10,705 to 2 significant digits. Does anybody have an answer to this question? Okay, I'm just checking. Sydney, are you raising your hand? I can't really tell.
No.
Okay, thank you. So what do you think? Or are you typing it in the chat? You can type it in the chat, guys, if you want, but if your microphone is working, it's better if you talk out loud, okay? So not quite. Okay, when we say 2 significant digits, what we mean is basically 2 numbers before, basically 2 numbers before any zeros at the end, or for a decimal, 2 numbers after any zeros at the beginning. Okay, so for this number in particular, if it were 3 significant digits, okay, it would be 107,000, right? And the 3 significant digits are 1, 0, and 7. And any numbers afterwards, as long as they're all zeros, they don't count. So this number could be multiplied by a great multiple of 10, but the 3 it would still be just these 3 significant digits at the beginning. Okay, but because this 0 is between 1 and 7, then this 0 is also a significant digit. So now that I give you guys an example that if I rounded it to 3 significant digits, it will be 10,700. Who wants to give a guess for what 2 significant digits would be? Just take a guess, no pressure.
Is it, wait, 11,000.
Yeah, very good. 11,000. And so you can see that the two significant digits are the two ones at the beginning, right? And we needed to round the 7 up because it's 5 and it's greater than 4. And we know that numbers greater than 4 round up. So it rounds to 11,000. Okay, thank you, Jaden. Let's look at the next question. What are the 3 components in division called? So when you're doing division, let's say we were writing it out like long division, okay? So there's a number here, right? There's a number here, there's a number here. These are the 3 components of division. Does anybody know what they're called? Okay, so Sydney said, answered it, thank you. Dividend, divisor, and quotient. That's correct, okay? So these are the 3 components in division, as in, what am I dividing by? What am I dividing it? What's dividing it? And what is the answer, right? So we have, so the answer in the 2 division question is a quotient. So if you were doing long division, this number here will be the quotient. And this number here is being divided. This is the divisor, okay? And then this number is doing the dividing, so dividend. Okay. You probably, generally we use words that are for the answer. They come up more, like quotient is the answer for division, product is the answer for multiplication, sum is the answer for addition, difference is the answer for subtraction. Okay, so these terms come up more, but divisor and dividend are the other 2 components. Okay, number 4a, what's a? 0 divided by 7, and b, 7 divided by 0. So 0 divided by 7 is a lot more straightforward than 7 divided by 0. Okay, so Sydney answered for 4a, which is 0. That's correct, thank you. Okay, so 0 divided by 7 is 0, right? 0 divided by 5 or 100 or -3 would all give me 0, because once I multiply 0 by 7, I get 0 back, right? But 7 divided by 0 is trickier. Chengxi, what do you think?
It's an accident. I accidentally pressed it.
Okay, why don't you just try answering? You know what? I don't think it's an accident. I think it's fate. Okay, so why don't you try answering?
Is it infinite?
That's a good guess, but no. Okay, so think about it. For 7 divided by 0, right? So 7 divided by 0 giving me an answer, it would have to mean that that answer multiplied by 0 would have to give me 7, right? That's how division works. So for instance, 6 divided by 3 is 2. That means that 2 times 3 gives me 6 back. But there is no number out there multiplied by 0 that would give me 7. Okay, and for this reason, we say that this is undefined. Okay. And if you put this into your calculator will say something like math error, or okay, mine just says math error. It might say system error, calculation error, something like that. Okay, so it won't even do it. But when we answer this type of question, we say undefined. Okay, so that's basically a keyword. Okay, so make sure you remember that. So if I ask you what's 5 divided by 0, what's 1 divided by 0, what's 3 divided by 0, tell me undefined. Okay, don't say no, don't say nothing, don't say impossible, don't say infinite. Remember, it's undefined. But there is a slight exception that we will talk about that in question 7, the bonus. Okay. All right. Now, number 5, what are the 8 and 2 in 8 squared, or pronounced 8 to the power 2, called? Express it as a power with a different base. Okay, so the first part, what are they called? I just mean in terms of their relationship in this power. This 8 squared is a power. Does anybody know what they're called in this power? Right, notice that 8 is the big number, 2 is the little number at the top corner. So does anybody know what that's called? Okay, so Sydney, you said that 2 is the index. So it is called the index in some editions. Actually, in the IB textbook, they use slightly different language than what is typically used in the Canadian classroom, and they do call it the index. Okay, but typically we call this the exponent. You guys should have learned BEDMAS, right? So if you've learned BEDMAS, then the E stands for exponents, right? And that's what they mean here. Okay. So and sometimes it is called the index. And then I should put it over here. Okay. And then the 8 is called the base. Okay. So you can remember it as it's at the bottom, right? So almost like in a building or something, what's at the bottom is the base. And then the little two at the top is the exponent. And then overall, this is called a power. Okay, express it as the power with a different base. So it's kind of given away there. So right now the base is 8, right? Do you know how to express that with a different base? So I want the same number, it has to still give me the same answer, but the base is different. And of course, when the base is different, the exponent will be different too. So, okay, so can somebody tell me what is 8 squared? What will that give me? Let's see who doesn't talk. James, okay. Do you know what is 8 squared?
4.
Sorry?
64.
Very good. Okay. And what does it mean? What does this 8 squared mean? It means that 8 is multiplied by itself twice, right? So 64 is 8 times 8. Now, when we think about it, we know that 8 can be expressed itself as a different power. Okay, so 8 is 2 times 2 times 2, right? Which is 2 to the power 3 or 2 cubed. I can't type powers with this, so I have to use this little hat-like key, right? That usually represents an exponent. So 8 itself can be expressed as 2 times 2 times 2. So then when we do 64, we know it's 8 times 8, but we can replace each 8 with 2 times 2 times 2, right? And we have 2 times 2 times 2 again. Can somebody count for me? How many 2s is that? However many 2s that is, that's the exponent. Okay, so how many 2s are there here? It will give me 2 to the power of what? Okay, so Matthias said 6. Thank you. Yes, so 2 to the power of 6. So that is my power with a different base, 2 to the power of 6. And if we write it out, it can be written like this. So in 2 to the power of 6, what's the base and what's the exponent? Let's have somebody who didn't answer yet answer. Who didn't answer? Sorry, is it Hattie or Haiti?
It's Hattie.
Hattie? Okay, do you want to give this a try? So in 2 to the power of 6, can you tell me what's the base and what's the exponent?
The base would be 2 and the exponent would be 6.
Very good. Okay. So the base would be 2 and the exponent would be 6. Great. Now, number 6. What are the 3 types of brackets? List in order from innermost to outermost. So brackets, those are used in English as well, right? In math, we need to have brackets so we know the order of operation. So that's what the B stands for. It's the number 1. So we always do it first. But we have different types of brackets for when there are multiple brackets in a question. And they're different depending on where they go. So from innermost to outermost. Okay, so Sydney answered this. And good thing these can all be typed. So yep, you're correct. So first, these rounded brackets. and then it's the square brackets, and then it's the curly brackets from innermost to outermost, okay? So let's say I had a question where it goes like this, just making this up. So let's say I had a question like this, right? These are the innermost brackets, the round brackets. So I need to do this first. And then I do the next set of brackets, the square brackets, okay? And then finally, we do the outside bracket, the curly bracket. Okay, so when you have multiple brackets in the same question, make sure that you're using these different types and recognize which ones you need to do first. Okay, and then the last question, which is a bonus. What is 0 divided by 0? So in question 4, we talked about 0 divided by a non-zero number and a non-zero number divided by 0, right? And 0 divided by a non-zero number is 0, and the non-zero number divided by 0 is undefined. But what is 0 divided by 0? Okay. So I just want to say first, it's not 0, it's not 1, and it's not undefined. Okay. So, but give it your best guess. Okay, so Matthias said any number. Yes, that's correct. So the basis of it is that it could be any number, right? Because any number multiplied by 0 will give back 0. So I could say that 0 divided by 0 is 5 because 0 times 5 will give me 0. I could say it's -1 because 0 times -1 would be 0, right? So I could say any number works, but we can't just say that mathematically or that it equals any number. So we have a term for this, and it's indeterminate. Okay? Indeterminate is similar to infinite, kind of. It's basically saying that there isn't one answer, but any answer will do, right? There's an infinite number of answers. So we say indeterminate. Okay, so those are the situations when 0 is the dividend or the divisor. 0 divided by a non-zero number is 0. 0 divided by 0 being divided by, or number dividing by 0, where that number is not 0, it's undefined, and then 0 divided by 0 is indeterminate. Okay, so some special situations there. Okay, so these are our warm-up questions. Does anybody have any questions about this page? What, anybody? No? Okay. So I have the answers on the next page. Okay, and this is like a typical PowerPoint for a class. So after the class, I would post this PowerPoint on Google Classroom. Oh, we usually use Google Classroom. So I would post a PowerPoint on Google Classroom. So you will have access to it. And for these types of warm-up, or I do a mid-chapter review, there's always questions and the answers. Okay, so you can still look at them later. Okay. So like I mentioned, this PowerPoint for today is from chapter 3, which is called Properties of Numbers. Okay, and I just put what pages it takes up in the textbook PDF. So the PDF of the textbook would also be on the Google Classroom. So you could, when at the start of class, you already have access to that, right? So you'll have access to it throughout, well, from then on. And I also assign homework from the textbook. Okay, so this is the contents for this particular chapter. And in this textbook, the contents are always labeled with the letters of the alphabet. So A, B, C, D, E. So there's usually around, I would say, 4 to 6 parts. Okay. So A is divisibility tests, B factors of natural numbers, C multiples of natural numbers, D directed numbers, and E roots of natural numbers. But then often within these contents, like there can still be multiple sections. So there might be like 8.1, 8.2, something like that, or there might not be. And depending on the length of the chapter, we definitely don't necessarily go through a chapter every class. Okay, so some chapters take 2 or even 3 classes. But some chapters take just 1 class. It depends on the length of the chapter and the difficulty of the concept. Okay, so A is divisibility tests. Now, I'm not sure you learned just divisibility tests in school or not, but in school, they generally only talk about for 2, 3, and 9. But we're going to talk about a lot more of that. Okay, so one number is divisible by another if when we divide the quotient is a whole number. And remember, we talked about quotient in the warm-up questions, right? Quotient is the answer for division. So for instance, if we have 12 divided by 3 is 4, then 4 is the quotient. Okay, so one number is divisible by another if when we divide the quotient is a whole number. So 12 divided by 3 gives me 4. 4 is a whole number, so I know that 12 is divisible by 3. But if I did 12 divided by 5, I will get 2.4. That's not a whole number, right? So 12 is not divisible by 5. For example, 15 is divisible by 3 because 15 divided by 3 is 5, but 15 is not divisible by 2 as 15 divided by 2 equals 7, remainder 1. We sometimes need to quickly decide whether one number is divisible by another. We don't want to have to actually do the division every time to check if a number is divisible by another, right? Especially when we're taking a really big number and dividing it. So we have divisibility tests for that. Obviously, this can be done using a calculator provided the number is not too big. However, there are also some simple rules you can follow to test for divisibility without actually doing the division. For example, we know that any even number is divisible by 2, and so its last digit must be 0 or one of the even digits 2, 4, 6, or 8. So this is a pretty basic divisibility test. You probably don't even consciously think about it because you know what an even number is and you know that even numbers are divisible by 2. Right? But if we think about it as a test, really it's that the last digit must be 0, 2, 4, 6, or 8. So any number whose last digit is one of these is an even number and is divisible by 2. And here we have the divisibility test of natural numbers. Remember, natural numbers are 1, 2, 3, 4, 5, so on and so forth. Okay, so we have divisibility tests for 2, 3, 4, 5, 6, 8, 9, 10, 11. Okay. And I would say that the ones for 8 and 11 are probably not too well known. Okay, so for 2, we just talked about it. If the last digit is 0 or even, then the original number is divisible by 2, right? So if we do, so we know that it doesn't matter what the first digit is. I'm just going to put an odd number. So 30, 32, 34, 36, 38. These are all even numbers, right? Because the last digit is 0 or even. For 3, if the sum of the digits is divisible by 3, then the original number is divisible by 3. Okay, so let's say we pick a number 139, 138. Okay, so take the digits and add them up. Okay. So 1 plus 3 plus 8 gives me 12. And then we know that 12 is divisible by 3. Then we know that 138 is divisible by 3. Okay, so take the sum of the digits, and if that's divisible by 3, the number itself is divisible by 3. Then for 4, if the number formed by the last 2 digits is divisible by 4, then the original number is divisible by 4. So when you look at the number, it doesn't matter how long it is. Okay, I'm just taking this number. Okay, when you look at the last 2 digits, so in this case, last 2 digits are 48, right? If that's divisible by 4, then the original number is divisible by 4. So 48 is divisible by 4, and this number that I just made up is divisible by 4. Of course, you want to make sure that you know your times table well, so you can do the mental math if the number made from the last 2 digits is divisible by 4. But I expect that from you guys. Next question, if the last digit is 0 or 5, then the number is divisible by 5. So, right, so let's say 30, 30, or 35 is divisible by 5. I start with this number, if the last digit is 0 or 5, is divisible by 5. Okay, so very straightforward, this one. Next one, 6. If a number is divisible by both 2 and 3, then it is divisible by 6. So this is more like, it's not the same type of divisibility test as the other numbers, because this one is dependent on whether it's divisible by other numbers, right? But 6 is divisible by 2 and 3. So if a number is divisible by both 2 and 3, then we know it's also divisible by 6. So apply the divisibility rule for 2, apply the divisibility rule for 3, And if it satisfies both, then it's divisible by 6. Okay, for 8, if the number formed by the last 3 digits is divisible by 8, then the original number is divisible by 8. Okay, so this is another one of those. It's very similar to the divisibility rule for 4, but it's the last, checking if the last 3 digits are divisible by 8. So let's say I have 15,232. Okay, so the last 3 digits are 232. Okay, and this is divisible by 8. Oops. Okay, if you're not sure, just divide it by 2 3 times, all right? And then if it's divisible by 8, if it's divisible by 2 3 times, then it's divisible by 8. So this one divided by 2 is 116, then divided by 2 again is 58, divided by 2 again is 29. All right, so I still get a whole number, it's divisible by 8. So then the whole thing is divisible by 8. I'm not sure. Okay, next question. If the sum of the digits is divisible by 9, then the original number is divisible by 9. So basically it's the same rule as 3. Excuse me, but then you have to check if the sum of the digits is divisible by 9, not just 3. Right, so if we take something we already know, let's say 81, I mean, we know it's divisible by 9, but I just want to show you some of the digits. 8 plus 1 is 9, right? So of course 9 is divisible by 9, and that means that 81 is also divisible by 9. Okay, for 10, if the last digit of a number is 0, then the number is divisible by 10. This one is very easy, even easier than 5, right? So because we know when we multiply by 10, we add a 0 to the number. So of course, the last digit of the number has to be 0 to be divisible by 10. Then the last one, this one is a little bit complicated. Okay, so add the digits in odd positions, add the digits in the even positions, find the difference between your numbers. If the difference is 0 or divisible by 11, the original number is divisible by 11. Okay, so I know that this sounds kind of complicated, but once you try to do it, it's not so bad. Okay, so let's do one of these. Okay, so I'm going to do, let's say 1,496. Okay, so when we say the digits in odd positions, I'm going to come over here. Okay, so digits in odd positions and digits in even positions. So the digits in odd positions are 1 and 9, okay, because they are, it's the first digit and the third digit. That's what they mean, okay? The digits in even positions, the second digit and the fourth digit. So 4 and 6. Okay. Then, so you add them together. So this one is 10, right? And then you add these together and it also gives me 10. Then we take their difference. So you subtract one from the other. Oh, typo. Okay. And if the difference is 0 or divisible by 11, the original number is divisible by 11. So the difference is 0, so we know that 1,496 is divisible by 11. Okay. And if the difference were 11 or 22 or 33, etc., that would mean that the difference is divisible by 11, so the original number would also be divisible by 11. This is definitely the hardest one. I would say the 11 divisibility test is the most complicated, and then the 0 divisibility test is probably the least complicated. Everything else is just in between. 3 and 9 are similar. Try to remember it as 3 and 9 are basically the same. 4 and 8 are really similar. 6 just 2 and 3, and then 2 is almost like common sense. You probably know it already. So I would say probably just 11. Maybe 8 and 4 that are a little hard to remember. But once you do some more questions, it will get engraved in your mind. So that's the divisibility tests for natural numbers. And that's basically every number from 2 to 11 except for 7. Okay, does anybody have any questions about this page? Anybody? I feel like somebody has a question, but they just don't want to ask it. No? Oh, you could, and if you have a question and you're trying to ask, you could always type it in the chat, just set it to direct message to me, and then nobody else will see it, okay? If not, let's go to the next slide. So we have some examples to do. Okay, so example 1, test for divisibility by 8 and 9. And we have 2 numbers. And then, okay, well, let's look at that first before we go on. So who wants to try for the first number, A? Larry, are you raising your hand?
Not anymore.
Okay. Oh, Changxi, you want to try it?
Yeah.
Okay, sure, go ahead.
So the last 3 digits is 240. 8 times 30, it goes to 240. So 8 is yes.
Very good.
And then 1 plus 3 plus 5 plus 2 plus 4 is 15.
Mhm.
I think. And then it can be divided by 9.
15 can be divided by 9, are you sure?
Oh, it can't.
Can't. Okay, so what does that mean about the original number?
So it can be divided by 8, but not 9.
Very good. Yes. Thank you. Okay. Does somebody else want to try for B? Okay, Larry, you're raising your hand this time, right?
The last one's not divisible by 9.
So you're saying, could you tell me your work for that? How did you determine that?
Well, I mean, if you add the last 2 numbers together, it's not divisible by 9.
Okay, so you're checking if it's divisible by 9 first?
Yeah.
Okay, sure. I'll put that over here. Okay, tell me, what do you get when you add 7 plus 6 plus 2 plus 3 plus 9?
Oh, wait, you mean everything? All right, just the last 3, my bad.
No, the last 3 digits is for checking divisibility by 8.
Oh, well, that's not divisible by 8 at least.
Okay, so if you add the last 3 digits.
That's divisible by 9.
Okay, thank you. Let's talk through the process. Okay, so last 3 digits, 239. You have to say that 239 isn't divisible by 8, right? Then you say 76,239 isn't divisible by 8. Oops. Okay, then when you check divisibility by 9, it's not the same thing as 8. Remember, it's a sum of all the digits. It's not taking the number formed by the last 3 digits. So sum of all the digits is 27. 27 is divisible by 9. And then 76,239 is not divisible by 9. But really, for whether it's divisible by 8, right? We didn't even need to do all this really, because we could have seen right away that it's an odd number, right? It doesn't end in 0, 2, 4, 6, or 8, so it can't be divisible by 9. No. Oh, sorry. Now what am I saying? I think my brain's not working. Odd numbers can. Okay, so let me just fix this. Oh, how did it go? These controls, sometimes you do undo work, sometimes it doesn't work. So yeah, sometimes you can kind of exclude things without really doing all the tests, right? If something isn't divisible by 2, it's not divisible by 4, it's also not divisible by 8. So we know that this is not divisible by 2 because it doesn't end in an odd number, right? The last digit is in an odd number, so we know it's not divisible by 2, then we also know it's not divisible by 8. So we don't really need to apply the divisibility test for 8. Okay, so that's something to consider. I guess I'll have to type this out again. Okay, let's look at the last question. When we know a number is divisible by 9, what else do we know it's divisible by? Let me just type this out again. Last 3 digits, 9, 239 is divisible by 8. Okay, so somebody said in the chat. Oh, okay, I thought somebody was answering, but no, okay. Okay, that's okay. So I'm sure somebody has a guess out there. When we know a number is divisible by 9, what else do we know is divisible by? Okay, is this the answer this time? Okay, yes, so Matthias said 3. Very good, right? So because 3 is a factor of 9, then any number that has 9 as a factor would also have 3 as a factor. So when we know a number is divisible by 9, we already know it's divisible by 3. So if you're checking whether, let's say you're checking for all the factors of a number, you can do the divisibility test for 9, and then you don't have to do the divisibility test for 3 if it already is divisible by 9. Okay, but just because it's not divisible by 9 doesn't mean it's not divisible by 3. But if it's not divisible by 3, it's not divisible by 9. Okay, so that's these questions for the divisibility tests. Does anybody have any questions? Anybody? You can also ask in the chat. Don't be shy. Okay. I do want to say that I've noticed that a lot of students don't like asking questions. Maybe you think it looks dumb, or you're thinking like nobody else is asking a question, so I don't want to either. I don't want to be the only one or something like that. I do want to say, please don't be shy to ask questions. It's very important to ask questions. And if you never ask a single question, it's probably a sign you're not doing it right. Okay, so if you don't understand something, really please ask. I'm sure many other people are wondering the same thing. And if you just never ask a question, you're confused, you're going to get more and more and more confused, right? Because we're still building on the same concepts. So yeah, okay, so really it's important to ask questions. Don't be shy, don't feel like nobody else wants to know, because trust me, somebody else wants to know as well. Okay, so before we move on, I want to hear at least one question. Okay, at least one question from anyone. Otherwise, we're not moving on. We're just going to stay on this page forever. Okay, so somebody somewhere ask a question. Okay, Larry.
Actually, I was in the question. I was just extracting this from my head.
Okay,
I was actually asking a question.
every time you do that, I think you're asking a question. Okay. Thank you. I have a good question here. Why doesn't 7 have a divisibility rule? Well, unfortunately, some numbers they just don't have divisibility rules. It would be nice if we had a divisibility rule for every number, especially for every single digit number, right? But unfortunately, we just don't have one for 7. I mean, even the rule that we have for 6 isn't really a real rule, right? It's just that 6 has 2 and 3 as factors, so we can say if it's divisible by 2 and 3, it's divisible by 6. But we don't have anything like that for 7 because it's a prime number. It doesn't have any factors aside from 1 itself, right? So unfortunately, we just don't have one. But that's a good question. I'm glad you asked. So yeah, unfortunately, if you're asked if a number is divisible by 7, you're going to have to just divide it by 7 to find out. Okay, good question. Thank you for asking. Okay, so let's look at the next part. So we're done with this 3A. So what I write on the PowerPoint at that point is I write the homework questions that are assigned for the exercise. Okay, so I wrote exercise 3A, 5, 6, 7, 8, 9, all. Usually when I write all, there's like the question has a B, C, D, something like that. And sometimes I only say like do A and C or do G and H. Okay, but if I say all, that means do it all. But notice that I skipped questions 1 to 4. So I usually skip questions that are very easy. Or very repetitive. Okay, so I'm going to just show you guys, this is a textbook. And again, if you were to join the class, right, you would have you would be given this PDF. Okay, so this is chapter 3, properties of numbers. And you can see that this is 3A. Okay, oops. So this is exercise 3A. Very nice. Skipped 1 to 4 because I thought they were too easy / repetitive, and I just signed 5 to 9. So 5, 6, 7 have A, B, C, D, or ABC. That's why I use the term all, but I just use it for single questions too, because I feel like it's weird if I say all and then I just have the number there. Okay, so I just want to show you guys that there's a really easy way to check your answers. So the textbook has answers to all the questions.
You don't get an accident to log out.
Okay, so if you click on the heading of the exercise, so if you click on exercise 3A, oh wait, this is not work. I swear. Okay, this works for the, this is weird. This works for the grade 8 textbook. I swear it worked for this text. I swear it worked for the grade 7 one as well. Okay, maybe it doesn't work for the grade 7 one, but in the grade 8 one, if you click on the heading, it will take you to that section of the answer. And then if you click back, it will take you back to the question, the exercise. But I don't know why it doesn't work for grade 7 for the grade 7 PDF. Okay, well, then you're gonna have to just do it the old-fashioned way. If you want to check your answers, then go to the back. It's always at the back, right? And just find whatever the exercise is. So in this case, is exercise 3A. Okay, so we can see that the answers are here, and you can check your answers here. So it's only ever the final answer. So let's say it was a really long word problem. You're not gonna get any steps. It just shows you the final answer, but that's better than nothing, right? And what you can do is check your work. And what I recommend is that if you're doing questions, don't finish the whole thing and then check your answers. Try to, especially when the questions are similar. So let's say you're doing question 5, maybe do A and B and then check your answer before you do C and D. Okay, because if you, let's say you got both A and B wrong, you probably know you're doing something wrong. So then you can look at your work, try to fix it, and then go on. So those are the homework questions. And when you see like this type of page on the PowerPoint, that's what it means. That means that these questions in exercise 3A are homework, okay? All right, let's go to B, factors of natural numbers. So remember that we already talked about what natural numbers are, okay? So the set of numbers that starts at 1 and increases by 1. So 1, 2, 3, 4, 5, so on and so forth, and goes on to infinity. Okay, so there's no such thing as like there being the biggest number in the world and it's 10 trillion or something, because it can always be one bigger. So we use these dot dot dots to express it keeps increasing without limit. So the factors of a natural number are the natural numbers which divide exactly into it. For example, the factors of 8 are 1, 2, 4, and 8, since 8 divided by 1 equals 8, 8 divided by 2 equals 4, 8 divided by 4 equals 2, and 8 divided by 8 equals 1. Woo. 3 is not a factor of 8, since 8 divided by 3 equals 2 with the remainder 2. 8 is not divisible by 3. All natural numbers can be split into factor pairs. For example, 8 equals 1 times 8 or 2 times 4. 1,856 equals 58 times 32. Okay, so when we say a number is divisible by another number, so let's say we say that 8 is divisible by 2, we mean that conversely 2 is a factor of 8. Okay, 8 is divisible by 4, 4 is a factor of 8. But 8 is not divisible by 3, 3 is not a factor of 8. Okay, so that's what factors mean. And when we talk about factors, they have to be natural numbers. So we can't say something like 2.5 is a factor, or -3 is a factor, or 0 is a factor or something. It has to be 1, 2, 3, 4, 5, 6, 7, so on and so forth. And all natural numbers can be split into factor pairs. So we can express it at the very least as any number is 1 times itself, right? And if it's an even number, it's 2 times whatever it is divided by 2. And the numbers can be very small, very big, doesn't matter. Okay, we're talking about natural numbers though. And most numbers can be expressed as more than one factor pair, right? So we said 1,856 was 58 times 32, but it could be expressed as 116 times 16, or 252 times 8, etc. Okay. Then when we write a number as a product of factors, we say it is factorized. Okay. 8 may be factorized as a product of 2 factors in 2 ways, 1 times 8 or 2 times 4. Notice that we do not consider 4 times 2 or 8 times 1 as different ways to factor it, because 4 times 2 is still the same as 2 times 4, and 8 times 1 is still the same as 1 times 8. Okay, so it can only be factorized as a product in 2 ways. These are not new ways. And how we usually express it is to put the smaller number first. So we put 1 times 8, we don't write 8 times 1. We write 2 times 4, we don't write 4 times 2. Of course, if the number is a perfect square like 16, then we just write 4 times 4. There's no way to separate that, right? 16 has factors 1, 2, 4, 8, 16 can be factorized as a product of 2 factors in 3 ways. So 1 times 16, 2 times 4, 8 times 8. Okay, and notice that when we organize the number of ways it can be factored, it's by the first number as well. So we write 1, the smallest one, then 2, the next smallest one, then 4, the next smallest one. And if it could be factorized as 5 times something, we will write that next. Okay, and then within the number, the pairs is also by order, right? So the 1 is smaller than the 16, the 2 is smaller than 8. Of course, the 4, there's no difference. You might have seen this expressed in other ways. So sometimes you're asked to draw a factor rainbow. Okay, so in this case, like it's like you draw arcs and then you write the factors at either end. So for instance, for 16, it would look like this. So this is factor rainbow. I don't think you're asked to draw these in this book, but just showing you an example. Okay, of course, the more factors a number has, the more arcs there will be. Okay, now even odd numbers. A natural number is even if it has 2 as a factor and thus is divisible by 2. A natural number is odd if it is not divisible by 2. I'm sure you guys know even odd. And then here we have, again, the homework. Okay, so notice for number, I skipped 1 to 3. And then for 4, I only assign E, F, G, H, right? And then 5, 6, 7, 8, all. So again, I don't assign every question. I think that'd be too much homework. And I don't think that's necessary because some of the questions get very repetitive. Okay, but when you're doing the homework, please do, take it seriously and leave yourself some time to do it. Let's say we have class at 12 p.m. We're just making this up. If we have class at 12, don't start your homework at 11:30. Okay. All right. Next part, prime and composite numbers. So some numbers have only 2 factors, 1 and the number itself. For example, the only 2 factors of 7 are 7 and 1, and of 31 are 31 and 1. Numbers of this type are called prime numbers. A prime number is a natural number which has exactly 2 different factors, 1 and itself. Okay, so pay attention to that. It must have 2 factors, 1 and itself. Okay, a composite number is a natural number which has more than 2 factors, and there's no limit on the number of factors that a composite number can have. From the definitions of prime and composite numbers, we can see that the number 1 is neither prime nor composite. So 1 is a special case. It's not a composite number. Obviously, it doesn't have more than 2 factors. You might think that, oh, it's a prime number because it has, 1 in itself as factors, but 1 is itself, right? So it only has 1 factor, 1, which is also itself, but a prime number has to have 2 factors because 1 in itself must be different. So every natural number is prime or composite except for 1. Okay, so please try to remember that. Okay, the number 10 is composite and it has 4 factors, 1, 2, 5, 10. Notice that 10 equals 2 times 5, and this factor pair are both prime numbers. Number 18 can be written as the product of prime factors 2 times 3 times 3. All composite numbers can be written as the product of prime number factors in exactly 1 way. Okay, so we are often interested in breaking down a number into the product of its prime factors. Okay, note, this is just the product of its prime factors. So we don't write 18 as 2 times 9 or 3 times 6, because at least one of those numbers is a composite number. But we just want to express it as a product of prime numbers. So in that case, we write 2 times 3 times 3. These are all prime numbers, right? And we organize them from least to greatest. That's why 2, the smallest one, comes first. But of course, if there are multiple 3s, it's the same thing, however you arrange the different 3s. Okay, but it's very important that we want to write them as a product of prime numbers. So to find the prime factors of a composite number, we systematically divide the number by the prime numbers, which are its factors, starting with the smallest. When we write a number as a product of prime factors, it is usual to express it in index form. So I usually just go with the terminology of the book, but that's a bit different sometimes from the terminology in typical Canadian curriculum. But when we say index form, we basically mean using powers. Okay, so for example, we would write 12 equals 2 squared times 3, right? So rather than writing 2 times 2 times 3, we write 2 squared times 3. Okay, now I'm going to show you guys how to express a number as the product of its prime factors. So there are usually 2 ways to do this. The textbook uses what's called the ladder method, but I prefer using the, I guess, tree diagram method, but it's up to you what you want to do, okay? And I will show you how to do both. So for the tree diagram method, first we write our number, so 252, okay? Then we branch off by dividing it by the smallest prime factor it has. In this case, we can tell it's 2, right? Because it's clearly an even number. If it's not divisible by 2, check if it's divisible by 3. If it's not divisible by 3, check if it's divisible by 5, etc. Okay, go with the smallest prime number factor. Then 252 divided by 2, just use mental math. Okay, somebody tell me what's 252 divided by 2. Okay, now I'm just like, are you scratching or raising your hand? No, I just think everybody's scratching because I keep thinking you're raising your hand. Come on, guys. I know you're good at mental math. Or you could have secretly typed into a calculator by now. What's 252 divided by 2? Okay, thank you, Matthias. So 126. Okay, good. So I'm going to circle 2 because it's a prime factor, okay? Now we're going to do the same thing with 126. So we're going to keep extending these branches in our tree until we get only prime factors at the ends. So 126, we can divide it by 2 again. You can tell that it's an even number, right? So we're going to divide it by 2 again, okay? And what is it divisible by? I mean, I should say, what is 126 divided by 2? Okay, well, okay, I want to see somebody else answer this time. I think everybody has answered at some point except for James. I don't think you've answered yet. Can you tell me what's 126 divided by 2?
63.
Yeah, 63. Now, 63, should I try to divide it by 2 again?
No.
I see. No, good. Why not?
Because it ends in an odd number.
Good. So it's not divisible by 2. So obviously I shouldn't try to divide it by 2. What should I divide it by then? I mean, if you just go through your times tables, you could probably figure out what factor pair 63 could be expressed by.
7?
Yes, so it could be expressed as 7 times something. But what I'm going to do is, so I could totally do that, okay? But what I'm going to do is I'm going to divide it by 3. I know it's divisible by 3 because 6 plus 3 is 9, which is divisible by 3. This way I can keep, you know, on the left side of the branch, I always have a prime factor. It's a bit more organized this way. But if you divide it by 7, that's totally fine, okay? What's 63 divided by 3? Well, I'm going to run out of space. I'm going to redraw this to a bit, so it's a bit flatter. Okay. So Matthias said 21. Thank you. Yep. Okay. Then 21, what is that? What can that be split into? One last step. Somebody, let's get us through this. Oh, I shouldn't have circled it. Oops, force of habit. Okay. I'm just circling the prime factors, and 21 is not prime, right? So I shouldn't have circled it.
3 and 7.
Good, thank you. Yep, so 3 and 7. Okay, and at this point, I'm going to circle all my prime factors. Well, that I haven't yet. So I already circled 2, 2, and 3. And I have another 3, and I have a 7. Okay, and I know that I can't go any further because 3 and 7 are already prime numbers. So there's no way to split them up other than 1, which we're not interested in, right? But we're not done yet. All we've done here is to find its prime factors, but we haven't expressed it in index form, which means using exponents, okay? So first, I'm just gonna write it out as 2 times 2 times 3 times 3 times 7. 252 equals 2. Okay, but sometimes this is enough, but again, this question specifies index form, so I want to use exponents to do it. Okay, so we can see here that there are 2 2s and there are 2 3s. That means that these numbers can be expressed using exponents. So who can try to say what that would look like in exponent form? Okay, I think I keep having to open and close the chat because it kind of blocks my window. So Sydney said earlier that that's correct, that it would be 2 squared times 3 squared times 7. Okay, so that's the answer. Remember, this exponent, this little number at the top right, means the number of factors, like the number of times the base is multiplied by itself. So squared means that the number is multiplied by itself, well, really once, but there's 2 of the number, basically, right? So there are 2 2s multiplied together. That's 2 to the power of 2. There are 2 3s multiplied together. That's 2 to the power of 3. And then there's just one only 7. So it's 2 squared times 3 squared times 7. Okay. And remember, we generally like to write the factors in increasing order. So we want to write it as 2 squared times 3 squared times 7, not, for instance, 7 times 3 squared times 2 or 3 squared times 7 times 2 squared. Okay. And if you want to check that, if you type in 2 squared times 3 squared times 7 on your calculator, you would get 252. So you did it correctly. Okay, so that's how you do it. Okay, and what are the prime factors of 252? Then we say 2, 3, and 7, right? We don't repeat, we don't say 2 and 2 and 3 and 3 and 7, right? Because a number, no matter how many times it's multiplied, that number itself is the factor. And make sure that you're just writing the prime factor. So don't say 21 or 63 or something. So that's how you do this question. That's how you do this question using the tree diagram method, which I prefer, but the textbook uses a different method, which is the ladder method. It's totally as valid. You could totally do that as well. Okay, I just wanted to show you guys how I do it. So, this is a picture from doing it before. So this is the ladder method. So for the ladder method, you basically keep dividing it by prime numbers until you end up with 1 at the end. So you could totally do this too. And I guess it's a bit more space efficient. So if you want to use less paper, this one might be better. Okay, so you start off with like drawing a little, almost like you're starting a chart. Okay, and then you put that the number in here, and then you divide it by the smallest prime number factor that's divisible, so 2, right? And once you divide it by 2, you write what it is divided by 2. It's 126, and then you just keep going. Okay, and then all the prime factors end up here. But then you have to be very careful that you're only dividing it by prime factors, and you're dividing it by prime factors that go into it. So let's say I forgot that about divided by 3 and I divided by 9, and I might just end up writing that 9 was one of the prime factors when it's not. Whereas with the tree diagram, if you end up with a composite number, you can just make another branch off of it, right? So pros and cons to both methods, but you can totally do either. And of course, you should get the same answer. So 2 squared times 3 squared times 7. The prime factors are 2, 3, and 7. Okay. Okay, so that's for prime and composite numbers. And then this is the homework for that section of the textbook. So this section of the textbook, like I mentioned, even though it goes exercise 3B, there's 3B.1, 3B.2. Oh, there's actually 3B.3. So the B section is pretty long. Next concept is highest common factor or greatest common factor. But before we move on to that, does anybody have any questions? Anybody? No? Okay. Well, after 4B.3, 3B.3, I'm gonna do the mandatory question again, okay? So highest common factor, or a number which is a factor of two or more other numbers is called a common factor of these numbers. For example, 9 is a common factor of 27, 36. We can use the method of finding prime factors to find the highest common factor, HCF, of two or more natural numbers. Note, this is usually called the greatest common factor, GCF. So this textbook says HCF and it says highest common factor, but usually in the Canadian curriculum, we say GCF, the greatest common factor. So I made this note for you guys, but for the sake of the textbook, I keep using HCF, but just get used to seeing both. Know that it's the same thing. It means the same thing. Okay, it's just H versus G. So example 3, find the highest common factor, HCF, of 18 and 24. Now, these numbers are pretty small, so you could probably just do this mentally. But there is a method using prime factorization to do this, and I think it is quite useful. So we're going to go over that just using these. But you know, you can probably just mentally figure out what's the highest common factor, right? So we're using prime factorization. What we first need to do is to factor both numbers, prime factorize both numbers, okay? So 18 and then 24. Actually, I want to see, I want some volunteers to do this. So I don't know if you used Zoom before, but there's a feature called Annotate where you can just write, where you can write on the screen. Okay, so I often have students doing questions using that feature. So I want to see two people, one person do 18, one person do 24. Okay, so Larry, you're really raising your hand this time, right?
No, actually, a question is, can I go to the washroom?
Yes, of course.
Also, people can use annotation. Also, they can scribble all over the screen because that can actually also happen. Just saying.
Yeah, you can either use the drawing feature, in which case, yes, you can do you can scribble like this if you want, but I would prefer if you use the annotate, but use the text, the text typing feature. So you type on the screen, okay? So everybody just try doing that just to make sure you know how to do it, because I do take advantage of that feature. So I want to make sure everybody at least knows how to do it. I heard that some computers, some people seem to not be able to do it. I feel like you should always be able to do it. That might just be that person's Zoom, they didn't figure it out or something. But everybody try to find the annotate feature and test it to make sure it works. Okay, so just type your name on the screen. Try to use it and type your name on the screen anywhere. So there should be, on my Zoom, it looks like a pencil. I assume it's the same for yours. And it says annotate. And then it will pull up a little ribbon. And there should be, for instance, draw, stamp, and text on the ribbon. So just choose text. That way you could just type. And that's how, I'm using annotate as well. That's how I've been typing on the screen. But you can do it on somebody else's screen share. Okay, so I see Matthias. Good. Everybody else try Jaden. Could you get Sydney? Hattie, does it work for you guys? James, Kenzie, try to type something on the screen. If you could, okay, so you're using the draw. Try to see if you can type. And if you can, then feel free to try the question. So Sydney, why don't you try 24? Okay, so do it on, you can try to do it on the diagram I already started, okay? Or you can start your own diagram if you want. Jaden, does it work? Is it working for you? Is Larry still in the washroom? Hattie, does it work? Does it work on your end? Yeah? Do you want to try 18? Okay, so yeah, I see Sydney has figured out the text and the drawing tool, which is good. Maybe draw a little bit shorter, otherwise you're going to run out of room. Okay, looking good so far, guys. And then circle the prime factors, okay? Good, I'm glad it's working. Wait, Jaden, I didn't see you type anything. Is it not working for you?
Hattie already did the thing, so.
Oh no, that's fine. But I just want to be able to see you right on the screen so I know it works for you.
Oh.
So does it work for you? I didn't see you type anything.
Yeah,
I can see it when people type something. Okay. Okay, Larry's back. Okay, good. Okay, great. Yes. Okay, so great job, guys. So 18 is 2 times 3 times 3. And I'm not writing it in index form right now for a reason. I will explain that. Okay. And 24 is 2 times 2 times 2 times 3. Okay. Now, prime factorization helps us to find the highest common factor, or later I will talk about it, the lowest common multiple. Okay, but it works slightly different for both. For highest common factor, what you need to do is basically look at all the factors that they share. Okay, so we look, and look, this is the best easily done in using prime factorization. So look at all the prime factors that they share. So we can see that they both have a 2, right? And then they both have a 3. But 24 has 2 more 2s and 18 has an extra 3, but we can't do anything about that because we only want to look at what they share. And it has to be the same number of that number, right? So we can see here that they share 1, 2, and 1, 3. So that means that the HCF is 2 times 3, which is 6. Now, with this question, the numbers are slightly smaller, so you probably don't want to do this and you don't need to do this, okay? You might be like, why would I do all this when I can just look at it, I know it's 6. Sure, you can do that with smaller numbers, but if you have like much bigger numbers, that's not gonna work, right? If I ask you what's the greatest common factor of 236 and 185, I don't think you can just look at it and know. So this method is much more useful for those cases, okay? But you have to make sure that you know how to prime factorize a number to be able to do this. So like I said, each concept builds onto the next. So make sure when you have a question, you ask it right away. Okay, don't hang on to it. It gets worse later on. So for this question, we see that 18 and 24 both share a 2 and a 3. Excuse me. So their HCF is 2 times 3 or 6. Okay, so good job on this, guys. So if we look at the textbook's answer, they use the ladder method. And they color coded it to kind of show us what factors are shared, right? So 2 times 3 is common to the factorization of both. So the greatest common factor is 2 times 3 equals 6. Okay. And these are the questions for 3B.3. Okay. Then the next concept is multiples of natural numbers. So we just talked about factors, and the multiples are a very similar thing. But again, before we continue, I want to just do a question check-in. Okay, so does anybody have any questions right now? And again, we're not going to move on until somebody asks a question, right? So somebody ask a question, and it has to be about the lesson today. Okay, so don't be like, what's the weather like or something. Okay, so a question about the lesson today, please. Larry, are you stretching again?
Okay, sorry about that. I try to use okay.
Oh no, it's okay.
So like like cause I know I was in the washroom, so I kind of missed like how to do this like the formula to do this one. So so it's okay if like I'm gonna repeat this thing.
Oh, of course. Are you talking about the highest common factor?
Yeah, because I missed the formula. I actually forgot how to do the formula. So
oh, sure, yeah, no problem. Let me see if I can bring back the drawing. I think I can. Okay, but you were here when we talked about how to prime factorize, right?
No, I was like I was asking about the part I missed. Because I definitely missed something.
Okay, so no problem. Yes, we can go over that. In the meantime, so I'm gonna go over this again, and then I just want everybody else, if you feel like you're fine with it, I want you to try a question, and I put that in the chat, okay? So just send your message to me, send your answer to me using the direct message in the chat. And okay, so when you need to find the highest common factor of two numbers, does this work? Oh, okay. When you need to find the highest common factor of two numbers, you need to prime factorize, like find the prime factors of the two numbers separately, which is what we did here, right? So in this question is 18 and 24. So either use the tree diagram method or the ladder method to find the prime factors of these two numbers. Then you write them out. Then you write this. So 18 equals 2 times 3 times 3. 24 is 2 times 2 times 2 times 3. Okay, so okay, is it okay to this point?
Yes.
Okay.
Oh, I'm good for.
And then after that, you just look at what prime factors they have in common, right? So we notice that they both have a 2 and they both have a 3. So their HCF is 2 times 3, which is 6.
I thought, oh, never mind. I thought it was 6. No, it's okay.
Yeah, so I mean, these are pretty small numbers. So even if you don't have to do this to find the HCF, you could probably just go through your head and be like, oh, it's 6, right? But if we have,
well, if it's like, I don't know, 1 million or something, then you probably need this.
Exactly. Yes, but don't worry, they're not going to give you 1 million or something, but definitely 3-digit, even for 3-digit numbers, right? As small as like 100 something, this would be useful. So nobody did the question. So nobody did the question I sent in the chat. I know it's only been like 2 minutes, but I feel like somebody should have gotten it already.
I did part of it.
Okay. Sydney, you didn't get it? Okay. So next it's okay if you didn't get it. It's more for like a bonus thing anyway. So next concept is multiples of natural numbers. Okay. Oh, and yes, I'm very glad you asked, Larry. Okay, so whether if you went to the washroom or even if you were here, maybe your audio fizzed out a little bit, or maybe you were drinking some water, or maybe you just didn't understand, please feel free to ask, okay? So yes, next concept, multiples of natural numbers. Okay, I'm getting a little bit of a sore throat from reading all this. Can I get somebody to help me read this slide? Many people have nice voices. Who has not? Jaden, could you read the slide for me?
Multiples of natural numbers. The multiples of any whole number have that number as a factor. They are obtained by multiplying it by 1, then 2, then 3, then 4, and so on. The multiples of 10 are 10 times 1, 10 times 2, 10 times 3, 10 times 4, 10 times 5, and so on. 10, 20, 30, 40, 50. The multiples of 15 are 15, 30, 45, 60, 75. The number 30 is a multiple of both 10 and 15. So you say 30 is a common multiple of 10 and 15.
Thank you. Okay, so and I only have one answer for the question I put in the chat. It's okay. So if you didn't get to finish it, it's okay. But if you already finished it, please do type it to me so I can check it for you. So multiple is almost like the opposite of a factor, right? If 2 is a factor of 6, then 6 is a multiple of 2. If 10 is a factor of 50, then 50 is a multiple of 10. Okay. And of course, the multiples of the first 10 multiples of 1 and 10 form the times table, which you should already know. So, okay. And just like how we can have common factors, we can have common multiples. So a number is if a number is multiple of 2 or more numbers, it is a common multiple of those numbers. So multiples of natural numbers. Now, this is like, find the common multiples of 4 and 6 between 20 and 40. So when they ask you like this, where it's like in a range, you know, like between this number and that number, you have to just list them all out, right? So between 20 and 40, I mean, you could start with 20 and then just stop at 40, right? Or if you go over 40, then we can see here that the common multiples are 24 and 36. Right, so for a range question like this, we kind of just have to list them out. let's see. But now the next, this is a very important concept, the lowest common multiple. So the LCM. So LCM, GCF, or as this book calls it, HCF, kind of go hand in hand. So the lowest common multiple of two or more numbers is the smallest number, which is a multiple of each of these numbers. Now remember, for factor, we want to find the greatest common factor or the highest common factor. But for multiple, we want to find the lowest common multiple. Okay, that's because if you do lowest common factor, it's always 1. If you do highest common multiple, there's no such thing because there's no such thing as the biggest number, right? So for factor, we want greatest common. For multiple, we want lowest common. One way of finding the LCM is to list the multiples of the given numbers until a common multiple occurs. So you could do that. So let's say find the lowest common multiple of 9 and 12. You could just keep listing the multiples until you see the same number, okay? So the lowest common multiple is 36. But we don't want to have to do this every time, right? Especially if one of the numbers is small, one of the numbers is big. Like if it asks for the lowest common multiple of 3 and 84, you're going to have to list so many multiples of 3 before you get anywhere near 84. Okay, or if the numbers are both big, this would also take a really long time. So we don't want to have to do that. And what we can do is to, again, use prime factorization to help us. Okay, so another method for finding lowest common multiples is to write each number as a product of its prime factors. By writing these products one above the other, we can include in the LCM only those factors that are necessary. This method is particularly useful for seeking the LCM of several numbers. Okay, so, oh, I forgot to leave a blank page for this. Okay, so I'm just gonna come over here. Wait, do I have time for this? Okay, so let's do this really quickly. And in fact, actually, let's look at 18 and 24 again, but this time we are going to do LCM instead of GCF. I still am in the habit of saying GCF instead of HCF because that's what is usually used here. Okay, so I have a screenshot of, I took a screenshot of the question earlier, so let's just go to that screenshot. Okay, so we found the prime factorization of 18 and 24, right? So this time, let's say that we are finding the LCM instead. Okay, so we still need to look at the prime factorization, but we're not going to do the same thing as we do for greatest common factor. Obviously, we're not going to do the same thing because it's a different thing we're looking for. So this time, instead of just looking at everything that they have in common, what we need to do is to use their factors to make a number that has all of the factors of 18 and 24. So we have to make sure that when we're putting the prime factors to build the LCM, we include all the factors of 18 and 24, but we don't want to repeat, right? So the most basic form, you can just multiply 18 by 24. It will give you definitely a common multiple, but it won't be the lowest common multiple. Okay, so we need to make sure we include all the factors, but don't repeat any of them. So this one is a little bit harder than GCF. Okay, so I noticed that 24 has 3 2s, right? It has 2 times 2 times 2, whereas 18 only has 1 2. So in this case, I know that my LCM has to have 3 2s because it has to have all the factors of 18 and 24. Okay, then I noticed that 18 has 2 3s and 24 only has 1 3. Then in this case, I know that I need to take 2 3s because I need to have all the factors of both numbers. Okay, but that's it, right? So I know if it has 3 2s, then of course 18 will go into it because 18 only has 1 2. If it has 2 3s, then of course 24 will go into it because 24 only has 1 3. And then let's just say if one of the numbers had like another factor that the other one didn't, let's just say this number had a plus times 7 for some reason, then we would also need a times 7 in our LCM. Okay, we always have a times 7 LCM, right? So basically the LCM has to have all the factors of both numbers, but don't repeat any. So if we multiply this out, okay, 2 times 2 times 2 is 8, 3 times 3 is 9, so it's 8 times 9, so it's 72. Okay, so the LCM of 18 and 24 is 72. Then if you just check it a little bit, 72 divided by 18 is 4, 72 divided by 24 is 3. So we know that it is actually a multiple of both. So it's the LCM. Okay, so LCM is a little bit harder than GCF, but it's a very similar idea. And also it's important to know how to prime factorize because that's necessary to do both. Okay, so, and we can see here that the way the book does it is they use the ladder method again, which you're very welcome to use. And then they do this a little bit differently. They kind of stack the factors into a table like this. To be honest, I've never done it like this and I find it a little weird. But of course, you're welcome to do this method, but I think that kind of just writing out the factors and just maybe like circling what they have in common is pretty effective. Okay, and then this is the homework for 3C.2. Now, okay, so this is just by the number of letters there are. This is halfway into the chapter. So usually halfway into the chapter, I put a mid-chapter check-in. If the chapter is really, really long, I might do like 1/3 chapter, 2/3 chapter check-ins. So then like I would usually give like 5 to 10 minutes for you guys to do this independently, send me the answer in the chat and I verify with each person, and eventually take it all together. But today we don't have any more time because it's already 5 o'clock. So yeah, we're not gonna do that, okay? But if this were a regular class, I would say like, okay guys, this is your homework from 3A to 3C.2. And then I would post the PowerPoint to this point, like to this slide onto the Google Classroom. And you would know that you should do the questions from 3A to 3C.2 if it were a regular class. But this is a trial class, so you don't have to do the homework. Okay, so that's 501 already. So that's it for the teaching portion of the class. It's been a pleasure having this class with you guys. I hope you learned something and I hope that you will sign up for the class so we can continue in the future, okay? Now is Michael, do you